Okay, so in this video we're going to have a look at sketching quadratics, and the question that I have on the screen is the type of question that we're going to try and build up to throughout this process. So there are a few topics that you need to know in order to be able to draw these quadratics and sketch them accurately. One of those is solving quadratics, the other is completing the square, and the final one that we're going to be also having a look at is the discriminant. Okay, so I'll link in the description all the videos for all the different topics that you're going to need to know well before we approach this topic. But if you're already happy with solving quadratics, you're already happy with completing the square, and you've obviously seen and used the discriminant, then obviously you're not going to need to worry too much about watching them, but obviously you do want to have a look at those first just to make sure that you're totally clued up on them. Okay, but we're going to get started on our first question, so here that is. Okay, so to start with, we're going to be having a look at this question here. So grab a piece of paper, grab a pen, make some notes, and we'll have a look at how to approach this question. So it says sketch the graph of y equals x squared plus 4x plus 3, labelling the minimum point and any points of intersection with the axes, and that could be on the x or the y axes. Now when we're doing a sketch of a graph, it is just that, it is just a sketch, so it doesn't have to be super accurate, but we do have to draw it in the right position and make sure that we show clearly all the points where it would cross through the axes. So we're going to have a look at how to draw a sketch here and all the different processes in order to make sure that it's as accurate as we can possibly make it. Now one of the first things that I'm going to have a look at, and you don't have to do them in any particular order, but I'm going to have a look at finding the roots or the solutions, and the process for doing that is obviously factorising it, and we're going to put it into a double bracket to have a look. So before I do a sketch of any axes or anything like that, I'm just going to get all of the numbers so I can kind of start to imagine how I'm going to draw my axes. So if I have a look at this equation up here, we've got x squared plus 4x plus 3, and we're going to solve it for when it equals 0, okay, when it's at ground level, when it's at the x-axis. So we need to factorise this. So our factors for the 3 at the end are going to be 1 and 3. There we are, and we can make 4 in the middle using 1 and 3, so we can have x plus 1 and x plus 3. There we go, and as that equals 0, we've got our two solutions there. For the first one, we've got x is equal to -1, and we've also got that x is equal to -3. So thinking straight away about the sketch that we're going to do, if we draw little axes, there we go, we know that it's going to cross through at -1 and at -3. I'm just going to draw a little sketch there, -1, -3. Now I want to get a little bit of a better understanding as to where the minimum point's going to be, and then I can obviously draw this in. Now one other thing that we also know is the y-intercept, and that's given to us at the end of the equation here, the +3. So I also know that it's going to cross over at +3. So let's just put that in. There we go, 3 on the y-intercept. Now obviously that there is giving me enough information to draw a little basic sketch. I can kind of imagine, I'm going to do it as best I can, a quadratic that goes through, there we go, and crosses over the y-axis there at 3. Obviously not a perfect drawing, but it is just a sketch, okay, and I've highlighted already where it crosses through the x-axis and also that y-intercept there that's given to us in the line equation. So the next step I was obviously identifying this minimum point as it's asked for in the question. And the process for getting the minimum point is to complete the square. So if I complete the square for that, let's have a look at that. We've got x squared plus 4x plus 3. And when we complete the square, we're going to halve that coefficient of x. So we have x plus 2 in our bracket squared. That enables us to get that 4x. But that would give us plus 4 at the end. And obviously we want plus 3. So that's going to mean we need to balance it out with a -1. And we can get the coordinates of our turning point there, of our minimum point. In the bracket we've got a +2, so our little x coordinate is -2, and we've got -1 at the end, so our y coordinate there is -1. And there's the coordinate of our turning point. And again, we now just need to label that on the sketch. There we go, so that's just here. And we're just going to label that as -2, -1, there you go. And you could even balance it out over here, look, by putting the -1 over here as well, although we don't really need to as long as we label the coordinate on the curve. But there we go, there are all the pieces that we're going to have to look at. So we're going to obviously be, what did we do? We did solving it, okay, by factorising and getting our two solutions for the roots. Then we also did the completing the square to get our minimum point, and the third thing that we labelled on was up here, already given to us the y-intercept. So they're the three things that we're going to be having a look at, and before we move on and before you have a go, we're going to have a look at one more question. Okay, so on to our next question, and obviously don't forget that I have linked in the description the videos for solving quadratics, completing the square, and I'll put completing the square in for harder quadratics as well, so that if you're not sure on that topic you can go right into depth with it, and then also obviously just having a basic understanding of what a quadratic graph looks like, this U-shaped curve. So let's have a look at this one then. So our quadratic there, we've got x squared plus 2x minus 8, and we're going to solve that for when it equals 0. So our factors that we can have for 8, we can have a few this time. We've got 1 and 8, or we can have 2 and 4. Right, okay, so how are we going to make 2 in the middle then? Let's have a think. So we can have 4 and 2, so we can have plus 4 minus 2. So we can have in there x plus 4 and x minus 2. There we go, that equals 0. We've got our two solutions there, so we've got our two roots. We've got x is negative 4 and x is equal to positive 2. There we go, so I can already start to get a bit of an idea of what this is going to look like. So a nice little basic sketch of an axis. We've got 2 over here, and let's put minus 4 over there. And again, don't worry too much about your scales being perfect. We are just drawing a sketch. Now I'm not going to draw this in just yet, but obviously we do have as well the y-intercept that we can label on, so we know that that's going to have to go a little bit further down, because minus 8 is going to be somewhere down here, not perfectly to scale, but there we go, there's minus 8. So I can try and draw this in as best as I can. I think before I draw this one, I'm going to wait just to get that minimum point, as obviously the roots are more towards the left of the axes. The minimum point is going to be on the left there of the y-axis, so I probably could draw a little bit of a sketch in. There we go, something like this. Oh dear, that wasn't very good. Just about. Okay, so it's going to look something like that. Maybe I'll draw that one again. It's not the easiest when you've not drawn it to scale, but there we go. There we are, a little bit better. Right, okay, so final part of the process then is going to be completing the square. So if we complete the square then, let's have a look. We've got x squared plus 2x minus 8. And when we complete the square, half that coefficient of x gives us x plus 1. That would give us plus 1 at the end. We want minus 8, so that's going to have to be minus 9 to balance it out. To get from 1 to minus 8 is minus 9. Okay, so I can label my minimum point on now. So let's do that. Let's write down here what the minimum point is. In the bracket, we've got plus 1, so it's going to be minus 1, and then the minus 9 at the end there. So minus 1, minus 9. So my minimum point is down there. Not the best for drawing on this one. Let's have a look. So imagine it's here. In fact, I'm probably going to redraw this just to make it a little bit better. Now that I have all the information, I can probably just make this drawing look a little bit better. All right, hold on. I've started getting rid of all the other bits there. So minus 1, minus 9. And let's have a think about drawing this a little bit better. Right, let's get rid of that. And let's make this a little bit better. Okay. And there we go. So we say that's minus 2, this is minus 4. And I'm going to draw this curve in first. I want the minimum point to be there. And then coming up a little bit, there we are. It's a little bit more accurate. Just try and make these as best as you can. So that is minus 8 for the y-intercept. And then the minimum point's down here, and that came out as minus 1, minus 9. There we go. Obviously that looks a little bit more accurate there. Obviously just being nice and careful. I have slightly missed going through the root there, so do try and make that as best as you can. Okay, obviously make sure you're using a pencil and a ruler for this. But there we go, that's how we're going to go about drawing the sketches of these quadratics to start with. We are going to have a look at quadratics that are sloping the other way or upside down in a second. But a couple of questions for these for you to have a go at. So make sure on each question you solve the quadratic to get your two roots, complete the square to get your minimum point, and obviously just reading the y-intercept from your quadratic equation up there. But there we go, here's a couple for you to have a go at. Okay, so here's two questions for you to have a go at, so pause the video there, have a go, and we'll go over the answers in a sec. Okay, so for the first one then, so factorising this we can have 1 and 5, and we want to make 4 in the middle, so that's going to be x plus 5 and x minus 1. So our two solutions, we've got x is minus 5 and x is positive 1. For completing the square, let's have a look. We want to halve that coefficient of x, so we have x plus 2 in brackets squared. And we want that's going to make plus 4, we want minus 5, so we're going to have to take away 9 there. So our coordinate of our turning point is negative 2 and negative 9. So drawing this as a little sketch then, we've got a positive and a negative root there, so let's just stretch that all the way along to here. So we've got minus 5 and we've got 1, and our y-intercept is down at minus 5 and our turning point is down at minus 9. Probably could have done with making that a little bit better. Let's just get rid of this. There we go, and let's just move this up slightly. There we go. There we are. So we've got a y-intercept down here at minus 5. There we go, and we need to just draw this in as best we can then. Something like that. There we go, obviously not perfect, it is just a sketch. And then down here, here's our turning point, and we want that to be labelled as negative 2, negative 9, And there we go. Obviously not a perfect sketch there, it's a lot harder for me to do this on the screen as well. Hopefully you can do that nice and accurately. Obviously with a ruler and a pencil for your axes and getting a nice smooth curve there when you're drawing it. But there we go, there's the first one. On to the next one. If we factorise that one, let's have a think. Our factors of 12, we can have 1 and 12, 2 and 6, or 3 and 4. We want -8, so that's going to be -2 and -6 there. So we have x minus 2 and x minus 6, which gives us our roots there of 2 and x equals 6. And if we complete the square, halving that coefficient, so halving 8 gives us -4. And when we expand that, we get 16 at the end, and we want 12, so we need -4 there. Okay, so the coordinate of our turning point is +4 and -4. There we go, +4, -4. So let's think about drawing this then. Both of them are in the positive quadrant there, on the positive part of the x-axis for the roots, and our y-intercept is at +12. Okay, so let's draw this out like this. There we go. Obviously just always highlight that y-intercept there. There we go, so the +12. So we've got +12 up here where it needs to cross through. There we go, and then down here we've got 2 and we've got 6. So 2 and 6. And the turning point is at 4 minus 4, so it's somewhere down there. Let's just try and draw this in. There we go. There we are, as best as I can. Okay, so for the turning point, we just need to label that on. So put that there, and that was 4 minus 4. There we go. There we are, and there's the sketch of our two quadratics. Right, okay, so hopefully you're happy with those. What we're going to have a look at now is quadratics that are sloping the other way, making that N shape rather than this U shape. So let's have a look at that. Okay, so in this question, we're asked to sketch the graph of y equals 4x minus x squared. And here we've got labelling the maximum point and any points of intersection with the axes. Now, when we have this negative x squared here, that just means that we're going to have, instead of a U shape like this one, we're going to have a little N shape sloping the other way. So there we go, that is what we're going to have to draw on this particular one, and that's indicated via the negative x squared. But again, we've still got to follow all those same processes in order to find out the points of intersection with the axes. So we're going to have to solve this, obviously by factorising it, and we're going to have to complete the square. And those processes are a little bit more complicated, but they're actually okay when we're actually having a look at these. So if we go about the same process as before and we solve it. So if we write 4x minus x squared, and we're going to solve it for when it equals 0. There we go. Now, one thing that I can do to help me factorise this, well, first of all, I'm going to rearrange it. So I'm going to write it as negative x squared plus 4x. Okay, you don't have to do this, but I just find to keep it in that same format as what we're used to seeing with the others just makes it a little bit easier, just obviously to see the solution here. Now, what I can do is I can multiply both sides by -1. Obviously, as we have 0 on the other side, that's not going to be affected. But if I times both sides by -1, it's going to remove that negative x squared for me. So if I do that, let's just write this times by, that's not a -1, here we go, times by -1. And I end up with positive x squared minus 4x. There we go. And now that still equals 0, because 0 times -1 is still 0. But now I can actually just factorise this, and it makes it a little bit easier just to see. So if we go about actually factorising this, it only factorises into a single bracket as there's no number at the end, telling us that one of the roots there must be 0, obviously because our 0 is our y-intercept there as there's no number. So if I factorise this, we get x brackets, and it'd be x minus 4. There we go, and that equals 0. So a nice little trick there when you do have these negative x squareds is just to multiply everything by -1 as long as you've got 0 on the other side. And then we can just get our two solutions nice and easy from that. We've got the first one there where x hasn't got a number with it, so for that one x equals 0. There we go. And for this one here, x equals +4. So there we go, we've got our two solutions. And actually we can probably go about drawing this sketch before we look at that maximum point now. I can actually draw this in, let's have a think. So I've got one solution, or one root here at 0, and I've got another one at 4. And because I know the y-intercept's also going to be 0, as that's where it crosses through the x-axis, I can draw a little basic sketch of this in already. There we go, and I can draw it in just like that. So that's what it's going to look like. I now just need to figure out that maximum point. So if I have a look, obviously that maximum point is going to be here somewhere. We do actually already know where the x-coordinate's going to be, because that maximum point has to be exactly halfway between the roots. And if I was to draw a little dotted line coming down, halfway between 0 and 4 is 2. So actually I do already know that the x-coordinate's going to be 2, but I just need to find that y-coordinate. So if I have a look, and to be fair, we could actually sub it in, but I'm going to follow the part of the process here for doing so, because obviously now we know the x-coordinate, I could actually just sub it into the equation there without completing the square. But I'm going to go about completing the square anyway, just as a sort of learning process in terms of how to complete the square for these questions, as sometimes we will be asked to complete the square, but there is a little bit of a trick you can apply in this, and we can just sub it in to find the value. But let's have a look if I actually go about this. So completing the square for this one. Now again, we've got it written as minus x squared plus 4x. There we go. Now if I want to complete the square for that, first of all I have to take out that factor of minus 1. So in a similar way to what we did before, we're going to take that factor out. So negative 1, and inside then I'll have x squared minus 4x. There we go. Now I can complete the square for what's inside that bracket, and again, don't forget I've linked the video to these harder completing the square questions, but I'm going to complete the square for what's in here, not forgetting the minus 1's there. But if I complete the square, we'll get x minus 2 in brackets squared, and there you go, there's our x-coordinate of 2, and that's going to give us plus 4 at the end, but obviously we want 0, so we need to take away 4. Now all of that is still got that minus 1 on the outside, so I just reintroduce that minus 1 on the outside of a big bracket, and I'm just going to multiply that back in, so we get minus 1 lots of x minus 2 squared, and it multiplies that negative 4 and makes it positive 4. And there we go, we can get our coordinates now from our completed square form. We've got x is 2 and y is positive 4. There we go, and we can fill that in and label that coordinate just there. Now as I said, obviously there is a little trick. I didn't actually have to complete the square for this particular question, although I do want to talk about it because on some questions, and the last ones we're going to look at, we are going to have to complete the square. But actually what I could have done, as I know that the line equation up here is 4x minus x squared, and as I applied that little bit of logic to find the midway point between these two roots, I could have just substituted 2 into there, and 4 times 2, looking at this now, 4 times 2 is 8. Take away 2 squared, which is 4, and 8 take away 4 is 4, so I could have found the y coordinate just from there, and that would obviously have been a lot quicker. But it obviously only works when we've got these nice x coordinates here, and it doesn't actually enable us to have a look at this process of completing the square. So I do want to discuss obviously how to complete the square for these. I think it's an important process to do, even though you should know that you know, in this situation we could have applied a little trick and saved a bit of time there. But there we go, let's have a look at another question. Okay, so for sketching this one then, we've got 8x minus 15 minus x squared, and again we're going to label the maximum point and any points of intersection. So if we go about this then, first of all I'm going to rewrite it in the format that I like. So I've got minus x squared plus the 8x, just rearranging these, and then minus 15, and we're going to solve that for when it equals 0. Now again I'm just going to do the same thing as before. I'm just going to times everything by minus 1, and we get positive x squared minus 8x plus 15, that all still equals 0. There we go, and now we can go about factorising this. So the factors are 15, we're going to have 3 and 5, we could have 1 and 15 as well, but to make minus 8 in the middle, we're going to want x minus 3 and x minus 5. There we go, so we've got our two solutions there. We've got x equals 3 and x equals 5. And there we go, there's our two solutions. So I can probably go about drawing this already. In this particular question, look, we do have a y-intercept. Our y-intercept is from our original equation up here, minus 15. So I can start putting this all together and having a look at what it looks like. Now if I draw this out, let's have a look. Both our solutions are positive. So in fact, let's just move that a little bit more to the right so we can see it a bit better. There we go. And that means we've got 3 and we've got 5. And in fact, let's move that along a little bit more because we also have our y-intercept down at minus 15, which is probably a little bit lower down. I'll try and do this as best I can. Let's try and make that there. So minus 15. There we go. And we've got 3 and we've got 5. Obviously, you can draw these a little bit more accurate on the paper when you've got your ruler and everything a little bit easier to scale. But let's have a think about actually making this a little bit better. In fact, let's start again on that one. So we'll draw an axis in. There we go, and we will get 3 and 5 over here. So 3, 5. I'll imagine this is minus 15 here, and I'll try and draw this in as best I can. There we go, and I'll stop it there. Okay, so we've got our negative 15 here, we've got our 3, and we've got our 5. We obviously just need to find the coordinates of this maximum point. So let's have a look at doing that. Now again, we could actually just apply a bit of logic. So just reminding you of this little process, in between 3 and 5, that's going to be 4. So I could just substitute 4 into that equation. Okay, but we are going to look at completing the square for it anyway. So let's have a look then, completing the square for this one. So this is the one I'm going to complete the square for, so I'm going to take out that factor of -1 to start with. So we have -1, and then that's going to be x squared minus 8x plus 15. So halving that coefficient of x, we get x minus 4 in brackets squared. That makes positive 16. We want 15, so that's going to be -1. And then re-bringing in that -1 on the outside and multiplying that out, that gives us -1 lots of x minus 4 squared, and -1 times -1 is going to make +1 at the end there. So we've got our coordinates of our turning point that we can read from that. We've got -4 there, so that's +4 as our x coordinate, which we already knew, and we've got +1 at the end, so 1 there. So our coordinate of our turning point is going to be 1. Obviously in this particular question, it depends on what you prefer. I don't mind completing the square, so I tend to just go for that process, but I could have just substituted 4 up the top here, and let's just check that out, make sure it works. It's always a nice double check. So if I sub 4 in, 8 times 4 is 32, take away 15, and then take away 4 squared, so take away 16, and what do we get there? We've got 32, take away 31, and that equals 1. There we go, so there's our y coordinate 1. So you can obviously take that process as well. Obviously that is a lot quicker, but just obviously bearing in mind, and I've said this before, that obviously sometimes we will need to complete the square because we may be asked to, so it's always good just to make sure that you're happy with all these parts of the process and that you understand obviously what that process is finding and how it works and different ways to go about it. But here we go, you can obviously choose on the next one. I will be solving to do it, I will be completing the square, I will be going through all those motions to get my drawings, but here's a couple for you to have a go at. Okay, so there's 2 questions here, so pause the video there, have a go, and we'll go over the answers in a sec. Okay, so for this first one then, so for the solving part, for getting our roots, I'm going to times it by -1 and rearrange it at the same time. So we've got -x squared plus 4x minus 3, and then we're going to times that by -1. So x squared minus 4x plus 3. There we go. So our factors there are 1 and 3, so it's going to be x minus 1 and x minus 3. And there we go, our 2 roots, we've got x is +1 and x equals +3. For completing the square, let's have a look. Let's take that factor of -1 out from the top here, so -1, and we get x squared minus 4x plus 3. Halving that coefficient of x gets us x minus 2 in brackets squared. That gives us +4 at the end. We want 3, so take away 1, and then reintroducing that -1. And that ends up with -1 lots of x minus 2 squared plus 1. So our turning point there is 2, 1. And then obviously we just need to draw a sketch, and obviously bearing in mind that we've got our y-intercept there, our y-intercept is -3. So we need to put all of these in. Let's have a look. 1. Okay, so 1, 3, minus 3 down there. There we go. And we'll draw that in. There we go. And labelling on that turning point, that maximum point right there, 2, 1. There we go. Obviously again, let's just substitute that value of 2 into our equation. So 2 times 4 up here. Obviously for our x coordinate for our turning points, we've got 8 minus 3 minus 2 squared, which is 4, and 8 minus 7 equals 1. There we go, so we've got our y coordinate definitely correct there. And on to the next one. So let's write this out in the format that we like. So -x squared minus 2x plus 15, and again there is our y-intercept, +15, and again timesing it by -1, so we get x squared plus 2x minus 15, and then we're going to factorise that, so it's 3 and 5, so we get x plus 5 and x minus 3. There we go, so our 2 solutions, we've got x equals -5 and x equals 3. On to completing the square, let's take the factor of -1 out, so -1. So we get x squared plus 2x plus 15, sorry, minus 15, I was looking at the line below there, there we go, minus 15. And then completing the square for that, we get x plus 1 squared, that makes 1 at the end, we want minus 15, so that's going to be minus 16. And then reintroducing that -1. There we go. And we get minus 1 x plus 1 squared plus 16. There we go. So our coordinate for our turning point there is minus 1, 16. Right, so we obviously need to get our sketch right. So now we've got all our points. We've got minus 5 and 3. So we're going to have, and what's our y-intercept? Plus 15. Okay, so here we go. Minus 1 and 3 plus 15. Let's have a look. Minus 1, 3. Our turning point is at negative 1, 16. I've just realised that I should say minus 5, not minus 1. Here we go. Let's get rid of that. That's our root over there, minus 5. Almost missed that. Minus 5 and 3. We've got 15 up here that he needs to go through. There's obviously not very good scale here because that's definitely not 15. There we go. But let's try and draw that in. Is it minus 1, 6? Oh no, it made a straight line. Let's do that again. Oh dear, that is absolutely terrible. Sometimes I think you just need to get rid of it and you need to completely restart. Only problem is if I make a complete mess of it now, it's going to look like a right mess. Let's have a look. Okay, so try and draw this one more time. So we have 3 and we have minus 5. And then this here, I'm going to draw a weird scale still, but there we go. That's going to be 15. Here's my minus 5, here's my 3. I'll do this, try and do this as best as I can. One last try. Arguably not much better, but there we go, we'll give it a go. And then labelling on that turning point, there we go, so minus 1, 16, there you go. And we've got our y-intercept there at 15 and our roots at negative 5 and 3. As I've said throughout this video, they are only sketches, so what's really important is obviously your labelling there, and not necessarily, you know, drawing an absolutely perfect sketch, okay? That's why it does say sketch. You are only doing as best as you can here and showing all those points of intersection on the axes. That's what's very important there. And obviously just making sure that they're in a logical position. Obviously what I struggled with my little drawing there was making sure that turning point was above the y-intercept and also on the left of the axes there. And some of those little elements can make this a little bit difficult when you're drawing the sketch. But obviously just try not to stress too much about getting the drawing absolutely spot perfect, okay? It is called a sketch for a reason. But there we go. That is obviously going about sketching our quadratics there where they're making a U shape and sketching our quadratics where they're making this N shape. Okay, so what we're going to have a look at is the next part of this process and just sort of putting it all together with a slightly different question. So here that one is. Okay, so I've got one of these for you to have a go at in a sec. So we're going to discuss this one here. So this question, it says 4x minus 5 minus x squared also equals or is equal to q minus x plus p squared where q and p are integers. So obviously that there is highlighting the fact that it can be written in completed square form like that, which looks ever so slightly different to the way that we've been writing it in the earlier questions, but we're going to have a look at how to actually write it like that. So it says find the values of p and the values of q. And then it starts to ask us some other little bits here. It says calculate the discriminant, and then it also says sketch the curve showing any points of intersection. So we'll have a look at those points step by step. To start with, we're going to have a look at obviously finding the values of p and q and writing it in this completed square form just here. So let's write it out. So we've got negative x squared, and obviously this is a bonus because we've already discussed how to complete the square for this. Okay, but let's have a look. Minus 5. So if we take out that factor of minus 1 to complete the square, we'll get positive x squared minus 4x plus 5. And completing the square for that, let's obviously halve that coefficient of x. So we get x minus 2 in brackets squared. And when we expand that, we get plus 4. We want plus 5, so we need to add in an extra plus 1 there. And then again, not forgetting to reintroduce that minus 1, because that affects that y coordinate at the end there. So minus 1. And we end up with minus 1 lots of x minus 2 squared. And then that turns that into minus 1 at the end. Now obviously it wants it written in this form up here, okay? Q take away those. So all that means is putting minus 1 at the start there, okay, and just shifting this minus 1 from the end and putting it here at the start. And if I write it out like that, we have minus 1 take away the 1 lot of that bracket, so I can get rid of that 1. There you go. And there it is. Minus 1 take away x minus 2 in brackets squared. So now it's in the format that we want. We can write out what the value of p and what the value of q is. So q is at the start, so q is the minus 1 there at the start, and p is negative 2 inside the bracket. There we go. And I always dislike that when they write it like this. Look, they've written plus p just here, and actually p's come out as a negative there, p is -2. So do just watch out for that. Just because they've put plus p there doesn't necessarily mean it's going to come out as a plus or a positive number. So the next bit, right, it says calculate the discriminant of this. Okay, now when we're looking at the discriminant, and again I've linked the video for that in the description, we're looking at the value underneath the square root in the quadratic formula, that b squared minus 4ac, which is called the discriminant. And it determines for us how many roots this is going to have. So rather than getting us to actually factorise this, if it does factorise, and finding out whether there are two distinct real roots, two equal real roots, or no real roots, we're actually working out the discriminants, okay? So if we'll put these values in then, let's see what we've got. So obviously we need to get the values of a, b and c from here. Now I'm going to take it instead from up here where I've rearranged it. So the value of a is that 1 in front of x squared there. So a equals the -1 in front of the x squared. We've got b, which is in front of the x, so the +4. So b equals 4. And then we've got to forget c as well, which is the number at the end, which is -5. So there we go, c equals -5. And if we sub all these values into b squared minus 4ac, let's see what we get. We get 4 squared, take away 4 times -1 times -5. There we go. And if we work that out, let's have a look, just multiplying all these bits together to start with. 4 times -1 is -4, times -5 is +20. So we have 16 take away +20, or 16 take 20, which is -4. So my discriminant has a value of -4. Now obviously what we know about the discriminant, obviously hopefully you've already checked that video out and you know about the discriminant. If we get a negative number, that means we have no real roots. So in terms of this quadratic that we're going to draw, it's not going to cross through the x-axis, and that's what that tells us. And obviously if we were asked to draw this curve and we weren't asked to calculate the discriminant, we might be sitting there trying to factorise it, we might be putting it into a calculator trying to get it in the quadratic formula, but actually very quickly we can tell using the discriminant whether it does actually have any roots. So it's a nice quick way for us to figure that out. And obviously this question asks us to do it anyway, but just thinking about another type of question, if it didn't ask us to calculate the discriminant, you know, it would be a nice quick way just for us to see whether it does factorise or not, and that's quite nice about the discriminant as well. So if we go about actually drawing this, if we want to sketch this curve, showing clearly any points of intersection with the axes, let's have a think about what it would look like. We know that it's going to be an upside down or an N-shaped quadratic curve here. So if I just draw a little basic axes, one thing we do need to get is obviously that y-intercept, which we've got up here. The y-intercept is -5. So that's going to be down here somewhere. So I'll probably want to draw this a little bit better actually. Let's get rid of that. Let's draw it so we can get actually down the bottom there. So we know it's going to be -5. We know it doesn't even reach the x-axis. There we go. The only thing we need to figure out is whereabouts we're going to put it. Now we can think about where the maximum point is because we've completed the square up here. So we've completed the square and we have got from that just here we've got +2 and -1 as our turning point. And if we go back actually finding that, let's imagine 2's there, -1 is there, so it's around here. There we go. So if I try and draw this in then, we've got it crosses through at -5. Got a maximum point there and it never touches the x-axis. And obviously just labelling this on, we've got -5 there, and that's all we need to label. It doesn't ask us to label the maximum point there, we could put it on if we wanted, but there we go, there is a sketch of what this curve actually looks like there. We got the -5, the y-intercept up from our equation up here. Okay, well, let's write that in, y equals -5, there we go. And we've got the fact of where the turning point was going to be positioned, just here from completing the square again, and then using the discriminants we figured out there was going to be no roots, so we know it wasn't going to get up to the x-axis there. So there we go, that's how we go about all of these points, obviously completing the square to find the turning point to get an idea of whereabouts it's going to be positioned. Obviously then getting the y-intercept from our equation and using the discriminant to figure out whether it was going to touch the x-axis or not. So there we go, that is a type of question that you could have, and I've got one here for you to have a go at before we finish. Okay, so here's your last question, so pause the video there, have a go at doing all of these bits, and we'll go over the answers in a sec. Okay, so for the first bit then, well, we need to complete the square, so let's rewrite this the other way. So we've got -x squared plus 6x minus 10. So taking out that factor of -1, we get x squared minus 6x plus 10, and then we can complete the square. So we have x minus 3 in brackets squared, that makes +9, and we want +10, so an extra +1, and then reintroducing that -1 again, we get -1 x minus 3 in brackets squared minus 1. So very similar to the last one actually. And if we rearrange that into the format that it wants, we get minus 1 take away x minus 3 squared. So obviously what we can take from that is our turning point here. We've got positive 3, negative 1. And also we can get our value of p and our value of q. So the value of q, if we do that first, q equals that number at the front, which is minus 1. And then p equals the number in the bracket, which is minus 3. There we go. Obviously we can also highlight our y-intercept here as well. We've got the minus 10 just up there. Okay, so y equals minus 10, just to remind ourselves of where that's going to go. And now we can go about this next step. So calculating the discriminant, we've got b squared minus 4ac. So b, let's just write them all down. Well, a is minus 1 again, b is 6, and c is minus 10. And if we stick those in, b squared, we get 6 squared, which is 36. And we're going to take away 4 times minus 1 times minus 10. And obviously figuring that out, let's have a look. 4 times minus 1 is minus 4, times minus 10 is plus 40. So we get 36, take away positive 40. So 36 take away 40 is minus 4. So the value of our discriminant here is minus 4. And that obviously tells us again, no real roots. We can't square root a negative number. So if we sketch this curve, let's have a look. We need to actually just draw it in to start with. And thinking about these numbers, it's going to cross through minus 10 and the turning point is at 3 minus 1, so let's have a think about what this is going to look like. So we'll say minus 10's down here. In fact, I could probably make that a little bit higher just to make it a little bit easier to draw. Let's just say minus 10 is there. There we go. And obviously that turning point is on the right hand side there, so it's going to go somewhere up like this. There we go, and that'll be 3 minus 1. If you imagine 3's here. Minus 1 somewhere up here, obviously not to scale. And there is a little sketch of our quadratic, just showing the fact that it crosses through the y-axis, it's sloping upside down, and that turning point there is in the bottom right quadrant of the axes. But there we go, that is how we're going to sketch some of these quadratics. That's how we use completing the square to obviously find that, and that is obviously how we use the discriminant to determine what a curve's going to look like when it doesn't have any roots as well. As all the other bits that we've looked at. But there we go, don't forget I'll link all the videos in the description for the discriminant, for solving quadratics, for completing the square with harder quadratics as well. It's all there, so do check that out, and hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.